Hello friends, this is Mr. Longo here, and in this video we are going to be given one trig ratio, and then we're going to find the other 5 that are missing, okay? So to do that, it's actually not that bad at all, especially if you remember the Pythagorean theorem. So you have to know a little bit about where certain trig functions are positive and negative. That's not too tricky. And you have to know the Pythagorean theorem to find one of the missing sides. Not bad. So let's do it. The cosine of theta is a positive 4/5. So we know cosine is positive whenever x is positive. So that puts us in either quadrant 1 or 4, the right side where x is positive. But tangent is negative. So since everything is positive in quadrant 1, tangent's going to have to be negative in quadrant 4. So we are going to draw our right triangle in quadrant 4. And of course, theta always goes as the reference angle, and we always draw with respect to the x-axis. Now, cosine is given as the adjacent side over the hypotenuse. So we're going to put a 4 on our adjacent side and a 5 on the hypotenuse. And this is where the Pythagorean theorem comes into play. We have to find this value down here. So to do that, it's just 4 squared plus x squared is equal to 5 squared. That should give you 16 plus x squared is equal to 25. So if x squared is equal to 9, then x is equal to 3. However, you have to pay attention to the fact that you are in a negative y territory. So our y value going down is going to be a negative 3. But now we have everything we need to finish the problem. All we have to do is take our sine is opposite over hypotenuse, so it's a negative 3/5. We were given cosine is 4/5, so that's still good. And then we have our tangent, which is opposite over adjacent, so negative 3/4. And of course, our reciprocal functions, we just take the reciprocal. So this would be a negative 5/3. This would be a 5/4, and this would be a negative 4/3. Yep, that's all you had to do. It's really simple to do. So the second one is very similar. All I want you to do is pause the video, give it a try on your own. As soon as you're done, click play, and let's see if you get it right. So give it a shot. Okay. So if you wanted to, you could have rewritten this as the sine of theta is equal to negative 5/13, just because it's a reciprocal. Maybe you're more comfortable with that. It honestly doesn't matter. Sine is negative when y is negative, so that puts us in the bottom 2 quadrants. And then cosine is negative, so that puts us in the left 2 quadrants, so our overlap should have taken place over here. This is where both sine and cosine are negative. Again, our theta is a reference angle. And now we have to do our sine, which is opposite over hypotenuse. So we have a 13 given, and our sine is opposite, so that's a negative 5. Again, all we have to do is the Pythagorean theorem to find the other piece. So that's just going to give us a negative 5 squared plus x squared is equal to a 13 squared, and you should have came up with x is equal to 12. Now again, this is where x is negative as well, so that is a negative 12. But we have everything we need now, so all we have to do is finish out the problem. Sine is opposite over hypotenuse, so negative 5/13, which we were practically given. Cosine would be adjacent over hypotenuse, so negative 12/13. And tangent would be opposite over adjacent, so that would give us 5/12. And then the rest, of course, are just the reciprocal. Here's that negative 13/5 we were given. Here's a negative 13/12. And here is your 12/5. And that's it for this video. Pretty simple, everyone. This is Longo, and I'm out. See you, bye.